Hello everyone, welcome to the lecture series on PLC programming. In this video, I am going to explain the concept of normally closed timed open contact, which is also referred to as NCTO. In our previous video, we saw the concept of NOTC, and this is exactly opposite to that. If we look at the operation, you will get a fair amount of understanding of how this is opposite to the previous concept that we have studied. However, let us start from the scratch. Let us take a look at the symbol and try to correlate with the concept of NCTO. So this is the symbol of NCTO. If you carefully observe, this tells you a lot of information. How do I say so? If you see, the switch over here is actually closed initially. So that means these are normally closed initially, and after some time period, say let us say there is a time delay of 10 seconds, they will open their contact. So it acts as short circuit initially, and after the time delay when they are energized, they act as open circuit. So that is why they are called as normally closed timed open contact. And this is the shortcut of remembering these type of conventions. If you remember the symbol, that fairly gives a lot of information on what the topic is all about. Now, having said that, how do we analyze this operation? It's very simple. Any contact for that matter, we need to check two conditions. What happens when we are not energizing them, and what happens when they are energizing them? So let's take a look by considering two important cases. Case 1, when de-energized initially, so I'm not going to supply any energy to it, and how does it operate? So in order to consider that, let us assume that we have connected this NCTO contact to a light load in this particular fashion. Now when I'm not initially energizing it, I have considered a push button switch, just to give you a demo so that it will be very easy for you to understand. So whenever I am not energizing this through the push button switches, it will be acting as closed contact, and current starts flowing from the source, that is from the input side to the load side, and light will initially be glowing if I am considering a light load. So you can try it for different loads as well. So now case 2, what I will be doing is I will be energizing this contact by pressing the push button switch. Once I press the push button switch, the timer understands that the energy is supplied to this contact, and that point of time it takes the time delay that is set within the controller. So if you're setting it for 10 seconds, for example, in this case, it starts counting 10 seconds from 0, 1, 2, 3, and up to 10 seconds it waits. After 10 seconds, what happens? It will open its contact, and as a result, supply to the load will be cut off and the light will stop glowing. Previously it was glowing, now it is not glowing. So this is one important observation. So this is exactly opposite to NOTC. So once we have an understanding of what NCTO is all about, let us look at the timing diagram. This will be the summary of the entire operation. So if you remember the timing diagram for these type of contacts, this will pretty much sum up the entire operation. So it's very important to have a clear analysis of the timing diagram. So let's take a look at the timing diagram. Now let me consider the push button switch over here as my input, and initially I was not turning them on for case 1, and after some time, let us say I will be turning this on, that is case 2 from this point, and again I will turn them off if you consider that as case 3, just to check how it varies the lighting load that is considered. So now what happens is, with respect to output, initially the output will be high because light was glowing up to this point. After this point, what happens? It is actually energized and it takes the time delay up to 10 seconds. So up to 10 seconds it will still be on. So after 10 seconds, what happens? The light does not glow because it acts as open circuit, and this behaves like an open contact at that point in time. So the output goes to 0 in this particular fashion, and after some point, if the input goes low, again what happens? It becomes de-energized. Whenever it is de-energized, instantly it will go to high state and be in on condition, and light starts glowing again. So this process takes place instantly. Once the input goes low, the output will go high. So that is one of the most important observations. I hope the timing diagram pretty much sums up the operation and you were able to understand this. In case you have any questions, feel free to reach out by typing in your questions in the comment section below. If you like this video, please do like it, share it, and subscribe to our channel for regular updates. Thanks for watching this video. Please do keep supporting. Thank you.